Good evening.
Good evening.
My name is Mayank Doi, and I have a background of remote sensing and GIS. And today we are going to discuss a little bit of basics of remote sensing and GIS particularly. So is everyone okay? Then we must start.
Yeah, please go ahead.
Okay. So today we are going to discuss about the basic of what is GIS and what are data types which are used. We are going to discuss in one single definition difference between GIS, GPS and remote sensing. And we are also going to discuss about the application of GIS in various fields. And we are going to discuss various software in the market right now and a little bit of how Python and GIS go in flow. And I'm going to tell you about the project I did on site suitability and land use land cover analysis. And then we are going to discuss about the future. So basically, what is GIS? The term GIS stands for Geographic Information and System. So the word Geographic Information System defines itself. Geography is everything that is around you. Information is information of that geography. And system is a compilation of hardware and software with which we can use, store, manipulate that information of geography. So that's how we are going to describe GIS. It's a simple term, but it has a vast meaning and understanding which is applicable in every field. So there are basically two data types which we use in GIS, that are vector data and raster data. When we talk about vector data, these are point, lines and polygons. So you can see on the screen, one is the real image and another one is a vector image. So in the real image, you can see the green is shown perfectly. And then there is little of village in around polygon and then a barren land, which can be easily marked with vector data with line, point, not point, lines and polygons. Okay, so that's how the vector data play. It only has three forms: point, line and polygon, with which we make all the vector data. Now the another one is raster data. So raster data, each grid of cell has a particular value which represent that particular information. On the screen you can see that the green part, every green part is given a particular number, let's say 1, and then the village is given a particular number 2, and then the barren land is given a particular number 3. So that's how it is interpreted. Every same thing which gives same value, we assign it a single value. So that's how the raster data is. I hope you have understood the difference between raster and vector. If not, you can currently see on the screen the difference, how vector data is shown and how raster data is shown. It's on the basis of the vector and raster, we do various processing on these two datas. Like suppose, talking about vector data, the shape of India, that would be in line, polygon, and the shape of its states like Rajasthan, Punjab, every state and its boundaries. So that would be represented with the help of only boundary we are talking about, with the help of vector data. But if we say we have a image of, तो every image की जो हर एक particular जो pixel है उसकी एक value होगी जो वो represent करेगा. So that would be a raster data. So now moving forward, we are going to discuss about what is the difference between GIS, GPS and remote sensing. Well, let's first talk about remote sensing. Remote sensing is a technique. Okay, GIS is a software and GPS is a device. Just remember these three things. Remote sensing is a technique, GIS is a software, and GPS is a device. So remote sensing is a technique with which we gather information about an object without getting in contact with that object. So that's how satellite get information, by remote sensing. They don't actually get in contact with the surface of the earth, but still they get the information. Now we all know in COVID-19 these temperature gun are being used. So it works on the same technology of remote sensing, without being in contact with the person, we get to know about the temperature. So that's why remote sensing is a technique. Now moving forward to GIS, GIS is a software that help us to work on the information we have collected using remote sensing. It also helps us to store, manipulate, and analyze. We are also going to talk about various software which are used in GIS in current industry. Now, I told you GPS. Now, GPS is a device. Okay, so mostly every gadget nowadays is have an inbuilt GPS. So now that GPS is connected to the various satellites which are hovering over Earth, which give us the exact location of our gadget. So that's why I told you, just remember these three things whenever you want to tell someone the basic difference. Remote sensing is a technique with which we extract information without being in contact with the object. GIS is software with which we process, analyze the data we have acquired using remote sensing. And GPS is a device from which we get the information of location. Now moving forward, there are many ways in which GIS is used in real world. So you can see various industries right now on the screen. Right from energy forecasting, let me tell you an example. Now currently for energy forecasting, a company called Torrent Gas is using site suitability analysis to place their gas pumps. So it is using GIS. Now agriculture, in agriculture sector, there are various startups coming nowadays which are working on this technology of NDVI, that is normalized vegetation difference index, which works on the health of the crop. So we can, with the help of remote sensing data, we can get the information, is the crop is healthy or the crop is diseased, or in which state the crop is it, because on the level of chlorophyll content in the presence of the leaves, we get this information. When the tree is very in the starting phase, it has very less chlorophyll content. But when the crop grows, it have an increased chlorophyll content. That's on that basis we determine with the help of remote sensing. Similarly goes with carbon management, and the aviation safety is the best GIS industry right now, because they have been using GIS from I think more than a decade, from the starting, I think so. So what they are easily tracking and also planning their way how planes and everything will revolve. Now about aviation safety, there is a software of ISRI ArcGIS. So what it does, it gives you an arc scene in which you can easily run. What it does, it syncs with Google Maps, and you can literally see your screen with every geography around you. So that's give you an idea of a real-time world, but not in current time, because that's a recorded image in Google Maps. Now Homeland Security, they have been using GIS for quite a time to track various kind of with the help of phone technology, they are using this. Now community growth, when it comes to community growth, population is increasing day by day. So how we are using community growth? With the increase in population, a city's boundaries also increase because people start living there. So with the help of GIS, we can easily map at what a city would look like in the near future and how much increase in population can happen. This I'm going to show you because it's one of the projects there is with land use, land cover. So now moving to disaster management with the current situation, COVID-19, GIS playing very good role. Hotspot creation is all done using GIS softwares, and also mapping is done using GIS software. Public health goes
Mayank,
yes, Rohit.
Mayank, is it okay that we go to the next one, because we'll be able to understand most of this things on our own?
I get it.
Yeah.
So let's move forward. So these are the same applications which we are talking about in various fields, so that you can do it by yourself, as I've also Rohit has also uploaded the link of the PPT. Now various GIS software in the market right now. Well, let's talk about first ISRI's ArcGIS, ArcGIS Pro, and various versions. Well, ISRI has been one of the best companies till now, because they have created a software which helps you in a lot of ways. It gives you an interface in which you can easily perform various tasks like load data, create tool, convert that tool into a Python script, and then make another plugin like that if you have a little bit more knowledge of programming. But it lacks is it is a private. You have to buy this product. But currently they were giving this license free because of the present situation of COVID-19. If someone is doing some project related to that, they were eager to give them a free license. And now moving forward to this next, QGIS, Diva GIS, and Dave Info, all three are open source software. QGIS is one of the good software which you can get easily and can work every bit from Python scripting to every toolbox you can, and there are also plugin, core and external plugins available for QGIS and Esri ArcGIS too. So what these plugins help? These plugins help us to create various good graphic database that helps us in various ways. Now moving forward to ADAS Imagine. ADAS Imagine is mostly used for processing of the data that we have acquired through remote sensing. For NDVI, it's best used for NDVI and various other processing things. We use ADAS Imagine like supervised and unsupervised classification. Classification can also be done in various software, but the layout of ADAS Imagine is so easy that it gives you an idea how easily it can be done. There are various other software in the market right now, but these are the ones which are mostly used. So now moving forward, well, Python plus GIS. So every software is made of programming language, but it's the interface that they create which makes it accessible for the common users. So, but if you have a little bit more knowledge of programming, then you can easily create more tools. You can simply join 2 to 3 tools that the software have actually created, and then make a new tool for yourself, or you can for others also. There is a field calculator in which you can easily calculate the area, the length, the perimeter, everything of a let's say India. We have an India boundary. We can easily calculate the area that the boundary is covering. We can also calculate the various person if we have a data of population in a particular square meter. Now moving forward to the toolbox. Toolbox has certain many types of tools which helps us in creating and also processing the data. And the best thing about these all software, ArcGIS, QGIS, MapInfo, there is a model builder present in there, which help us to, we talked this earlier, export our tool to a Python script, which then can be easily used to modify the software. Now, this is one of the project I did using site suitability analysis. What we did in this software was we acquired, we were creating site suitability for dumping site. So obviously we don't need dumping site near river, street or park. So first we created a restriction model. After creating restriction model, we made a map which give every cell a 0 and 1. 0 for a cell which is restricted and 1 for viable cell. Then we move to suitability model, in which we give weight and criteria. Like we have 3 criteria: slope, land use, and distance from the dump site. So we give slope 60%, we give land use 25%, and we give distance to 15%. Now applying these weights gives us a suitability model which we can easily use. Now the third comes is suitability parcel creation. So this, which you can see on your screen, is after suitability parcel, in which we multiply the restriction model we have created with suitability model, and it gives us a certain results in which I have applied area less than 10,000 square kilometers. So these the parcels you can see on the screen, and the one selected parcel is one of the best site which I thought would be, because it's near to the city, and as the city is increasing toward other places, this would be great because this divides the city. Now moving forward, these were the data like road network map we have used from OpenStreet database. If I'm correct, Rohit, that it's OpenStreet mapping is done using GDEL. Hello. Hello. Okay, how exactly? Not aware. Okay, now let's get back to our presentation. So basically, OpenStreetMap is the from where we get the data like road network, river. We can easily get data of any place. Let's suppose say we want to know get the database of Delhi, that metro lines. So every we get it easily with the help of various open source website available. Now on the screen you can see the suitability model and multi criteria model. Before it was the restriction model. So now these are the tools which I created. So with the help of this was done in ArcGIS. With the help of similar can be done in QGIS. Now with the help of Python scripter, we can easily convert this tool into a script which can be used for further modification. Now, I told you about how we can see how a particular area will be changing. So this was which we did, how we saw how 1990 image and we took 2015 image processes and found out how build-up land has increased from 1990 and 2015. We can easily calculate the increased area with the query builder present in these softwares. So it's quite helpful and the interface is also quite good. So now let's talk about road ahead. Well, I saw one of the videos of Rohit on working on LiDAR. Well, LiDAR I think is currently in the starting phase of India market. There are some companies, good companies working with LiDAR data. What happens? LiDAR data consists a lot of data, and every point on this LiDAR have a lot of information. Like it sends LiDAR data, LiDAR sends a light detection and ranging. So it sends a laser pulse and it records every point. So every point have information in X, Y, and Z coordinate, which is used for mapping. So I think this LiDAR data is very helpful in for smart cars, which will be we can see in the near future, and also for the drones movement. I think it will be very helpful. Now 3D mapping it's already happening, but 3D mapping can be taken to a next level with the help of LiDAR and plus GIS. Now holographic GIS is one of the things that you just easily take your phone and you can see various, where is the pipeline going, where are the cables going. Now how can a software show that? If it has inbuilt, system which have already mapped everything like cables to paths to everything. So a lot of acquisition of data has to be done in India currently, which is already taken in various, like US, which are developed countries. So not talking about Indian market, there are many remote sensing and GIS companies working in this market. Now, all these companies are mostly in public-private partnerships in starting phase, but as soon as they get projects, they easily can acquire data. So I think if this data is made available at a certain price or even free, a lot of startups can work easily and come forward with this technology as it will change the near future. So that was my point of view that I was thinking of discussing in this presentation. If anybody have any question regarding the PPT, then I would like you to please speak.
Yeah, in case there are no questions, then we can maybe just go ahead with the Dhritaraj's presentation. I found it very nice. Aman, thank you so much. You've been very helpful in giving us a very clear understanding of what is the difference between GIS, GPS, and all of these things. And I actually had no clue that this is being used for planning in this manner, that you are modeling with those different parameters, which is distance and all that. So this was something new for me. I had absolutely no idea about that. So that is wonderful. Thank you so much. And I think everybody else also found it quite interesting. So guys, if no questions, can we move on with the next presentation? That's okay. Anybody's got any questions right now? Perfect. Thank you. Thanks a lot, Aman. So we'll go ahead with the next presentation, and then I'll try and wrap up in the end with few things that I have either noted right now or few other things. Dhitraj, please go ahead, present your screen. Thank you so much.
Okay, thank you. Thank you so much, Mayank, for
Welcome,
giving
sir.
a brief. I've been studying as well. I've studied the geography
Yeah.
since my undergraduate, and it's been very nice to brush off my basics as well. Thank you so much, everyone, for joining in. I'm Dhriti. I am currently based in Shanghai, China, right now. I understand this is a very interesting point of time to be in China at the moment, but has been very it's very interesting country. It's been very fantastic for me as well, personally. Um, Today I'm going to talk about a tool again, which I've been used for my PhD, my entire PhD study, and the few initiatives which I'm very much looking forward to take up. I've already started, but I'm looking to see if anyone would be interested, and that's how I connected with Rohit ji to see what we can do. And so I'm going to talk more about Google Earth Engine and how I've used it, and a few case studies about it, and then what I'm really planning to do for India and how everyone we can do it together. So, well, to begin with, I'm sure you all know Google Earth, and you've been using that to do a time series. You can check all the images and see it's wonderful. So you can see forest loss in Assam. You can see urban expansion in Shanghai. You can see deforestation in Brazil. But in order to quantify, as Mike was saying, that you use ArcGIS and Air does these fantastic softwares. But if you ask Mayank, if I ask him to do NDVI, which is the vegetation index, which you can see here, if I ask him to do for 30 years of time series analysis, it will take him at least 6 months to do it, because you have to download 30 years worth of data.
Dhritaraj, sorry to
And
interrupt. Are you sharing your screen? I can't see your screen.
oh, I'm sorry. I'll check again.
Well, that's true, Raj. You were saying that it would take more than 6 years.
Yeah. Can you see my screen now?
Yeah.
Yeah.
Ca-
Yes.
Okay, right. So it will take good amounts of time to download these data set and do it. So what is happening now is the advent of cloud computing and machine learning, but especially cloud computing, that you can now have your satellite imagery up in the cloud. So you can perform your analysis, perform your quantification using Python or JavaScript, perform your analysis there, and just download your final result, right? So that's what we want. That's what I want as a researcher, that I don't want to do so much processing on my computer. I just want my results so that I can write my analysis. That's what I want to do. So researchers around, what with Google Earth Engine has happened, that now there has been efforts to map infectious disease such as malaria or COVID-19, um, manage water resources around the world, deforestation, biodiversity, and also glaciers up in the Himalayas to look at climate change impacts. And these all are being done in cloud computing in a matter of 10 seconds. You have your result, because it helps you in then making decisions, right? So that's what it's doing. I'm not bragging myself, but I can do vegetation index. I can calculate forest loss in 10 seconds because I have the code ready. I know where to put in my data set, and I can perform it. You can. The reason I'm able to do this is because of Google Earth Engine. It was launched in 2015, and what it is actually Google has uploaded all the freely available data sets. So you have Landsat, Sentinel, MODIS, all, even from ISRO, even from all the countries, Sentinel, Copernicus in European Union. They are putting up their data sets free up in the cloud. So they're uploading. What Google is doing, that they are downloading it from the website from NASA, Space, ISRO, and they're putting up in their cloud, and they're giving you a simple API using JavaScript or Python so that we can just do our calculation using a few lines of code. And their data catalog is huge. It's getting more and more every day. These are public data sets. More than 500 public data sets are just available and free to use, and they're more uploading every year. So you're looking at 10 to 30 meter weekly. You have MODIS, you have vector data, you have looking at land cover data set. We are looking at weather and climate, which are already there available for us to freely use it. And so I've been a very big supporter of open source, and I've been working on it, especially in terms of remote sensing. And so what Google Earth Engine does is that gives you this user interface where you can put in your code. You have a simple code. You want to do NDVI. You want to see time series. You get a chart, and then you export that chart and you start your analysis. So you spend less time in processing in hardware, dealing with hardware and software, which is a major issue when it comes to remote sensing analysis and quantification. So what you're looking at was mine was telling you about land use classification. This is a 7-line code of machine learning. So what you're doing here, you are training with your training data set. You're using the decision and regression trees. You have your training data set. You put your class property and your images, and what you do, you classify and you put that on the map. So these are 7 lines. You do it for 1 year, and you change the date, and you have a time series analysis of land use cover. This is missing for India. We do not have a freely publicly available time series data set of land cover in India, nationally available, which you can just directly download one single image. It's not there because right now even masters and PhD, it's all about doing land cover classification, which you can do just here right now in 10 seconds. So the idea is now to more use these to do effective decision making and spend less time in just removing the cloud, masking it, getting an image, geo-rectification. It takes a lot of time. So with these technologies coming, cloud computing, there are a lot of work being done, and I'm going to show you a few case studies. This is a global forest change, which was done by University of Maryland, the first ever global data set, time series data set of forest cover change throughout the world from 1985 to 2018, 32 years worth of data. This is another example which was done in India by it's the Center of Wildlife Studies, and what they saw, like how a forest cover changed after a few places were declared as reserve forest. You can read this paper. I have the link here. Another work was done to map malaria. This was done by Oxford University. What you see on the screen here is a global friction map. What it means that how much time it takes to travel. And when we travel, we are carrying the disease as well. So as you can see, this was done for malaria, but I'm sure if you plot this for COVID-19, it will be very interesting. All the hotspots around the world are places where you can travel very easily, right? So it takes around 1.5 hour, 1 hour to travel within India. Places around, well, let's say 1.5 hour, but yes, by flights you can, definitely not our trains. But in Europe as well, it takes less hour. But you see, there are places in Africa, places in Australia as well, where it takes more time to travel. So this was done using digital elevation model. This was done using road networks. Done in India using freely open source, publicly available data set using chirps, uh, um, which is a precipitation data set available in Google Earth Engine. And it just provides you a precipitation data set at a basin level, right? So I've given you the link, you can check it out. And this is something very powerful, and it's missing in Indian context. So this is for rainfall. Imagine if we have this for drought, for floods, and these are very helpful, not just for education, but for decision-making purpose as well, and at a local level. So you're looking at the city level analysis for your own city, and this is very, very powerful. And something I'm really have to share this. There's a very interesting thing that we can learn from China is that they use their geography very good. So they know what's happening where in their country because they have a very good user interface, which they can use it, their data set and what's happening where. So they have data, and data is very useful, especially geospatial data set. Another example, which is done by H3, and I'm a big fan of H3 in Bangalore, and they use a lot of machine learning, a lot of Google Earth Engine to map forests, to see biodiversity change, to see how lockdown had affected, to see if tourism affects forests, to see how climate change is affecting, and to create a publicly available user interface to see what's the impact. Because these data sets are always in the files and big scientific papers which are not really acceptable to public. My parents cannot understand, but a very simple map and user interface and app gives that it acts as a bridge to understand data very easily over a map. And that's something I'm really interested in, making those user interface to make data more accessible and more visually accepted for people. With Google Earth Engine, I'm from Guwahati, I'm from Assam. This is where my hometown is. It's Panbazar, and I've been working on trying to work with people in Guwahati to map. I'm very much every year in Assam we have floods, and it's been going on since 1990s, and there are people lose life and property. They are farmers, so who cares? But with this platform, we can monitor these changes at a monthly level and help those people on ground to see what kind of rehabilitation or mitigation we can do. So here you're just looking at one single point. You're looking at an NDVI, like you're looking at vegetation index. You're looking at a linear regression here, basically, and it shows you a downturn, basically deforestation. But this is done for 1 pixel, but you can do with Google Earth Engine, you can do for this entire area, get your results in 10 seconds, make up your report, use it for decision making, saves a lot of hassle. So this one is for one single point. At the same period of time, you can do a harmonic modeling where you can see how different crops, for example, they behave. So you're looking at an evergreen forest, which doesn't have a harmonic much. You have a one crop here, you have another crop where you can see a harmonic model. It's been used for crop identification. And I think once we have this, and once it's more accessible for people to use it, I'm sure it will be very useful for a community to use this data set and to see, okay, fine, this is what have changed in 30 years. So we can accept what can happen in the next monsoon. So we know which crop to sow. And I think that education needs to be done when we have these user interface ready with us and we have these results. And with Earth Engine, I have this code ready. We don't have to do much, change the points. I have the basic knowledge. I have the domain knowledge. And what we need is like a user interface which people can relate this to. Another example, which was done by the European Space Agency, was the Global Surface Water Data Set. It has 35 years of data set of where surface water has gone down, where it has gone up. So the main example, I should have put in a picture here of the Aral Sea. I don't know how many of you know, but Aral Sea is one of the major examples of climate change, where the entire sea has now shrunk into a small little lake, and due to climate change. So there's a lot of surface water change going on, and it's certainly something to see for India, which we struggle every year in Maharashtra. We struggle with drought, and with available technology, satellite technology, I'm sure with all of your help, there's a huge data set available which we can train our models, and to see how much in which area exactly there will be the changes, so that we can effectively plan our future agricultural industry. So something which as a researcher, I really support remote sensing, and I work with United Nations. Not work, I volunteer for United Nations outer space affairs, and what they are encouraging to use is satellite remote sensing data set, because I tell you, Landsat, currently their archive is more than 8 million images, and out of 8 million, only 90,000 images per year are used, because rest of them are not just used. We are not using those high resolution images to interpret what's happening on our earth, obviously, because we have software issues, we have hardware. But I think with this with computer science and developing so rapidly and so wonderfully, that we can now do so many things which could not do even 5 years ago. So something which I have done is I've published the papers. Of course, like as a PhD student, you have to publish papers, which you have to grow like that. But I've worked on reclamation, things which happens on the coast where you build land on the sea. And this is various cities in China where Chinese coast have just rapidly, there's a rapid degradation of paddle flats, and that has affected their ecosystem here a lot. But you can also do like things like their data set which calculate nighttime light data, which helps us to see and quantify urban expansion, to also not only urban expansion, it just tells you where we are. So you're looking at expansion in the Europe here. So you see nighttime light data of 1992 in Europe, and then in 2011, and you see this expansion in Poland, in other places. And this just tells you the amount of pressure we've been having on our land resources. And that just tells you a bigger picture, but it also gives you an opportunity to further plan and process and to see what's going wrong. Another application which I've done with Google Earth Engine is to track typhoon. To be honest, currently right now in Shanghai, it's been raining for past 24 hours. There is a typhoon coming up. The animation you're looking at is Typhoon Mangkhut, which hit Philippines and then Pearl Level Delta in China in 2018. What you're looking at a Sentinel-1 imagery synthetic aperture radar, where you're looking at tracking the typhoon every day as it approaches. So it just helps you. And I think Indian Meteorological Department did a fantastic job in tracking Amphan cyclone, which hits last month. And that was a fantastic application of remote sensing and GIS in a public domain. And I think we need that more in open source. We need that more to support our governments. We need that kind of application in other fields as well. So I'm trying to do that, right? So I'm trying to do all these things, and I have created, and I'm doing more. I have created this dashboard, which is, I'm sorry, it's written ocean, but it's actually land surface temperature. So you're clicking on a point here, and it gives you 35 years worth of data of temperature and how it has changed over a few years from starting. This is just for 2017. So you're looking at time series data set. I have created this user interface. So you click anywhere, you get your data, and this data can be used to train. So if I have 5 years worth of data set, I know that I can do a regression or machine learning to see what could be the next 5 years, and that will be very helpful for farmers in Vidarbha or farmers in northern India. And that data set, if we are able to make and communicate with those data set, that's something which I'm really interested to work with. Something which I did again, because I work on coast, is sea surface temperature to monitor typhoons, to monitor how ocean is warming. And based on that, you can calculate if we're going to have a tropical cyclone sooner or later. This has been used by Indian Meteorological Department, but I'm using it as well for my study. And well, the data set from IMD is still not public. I'm not sure if it's publicly available or not, but it's troublesome to acquire. But I'm sure with available data sets, there are plenty other data sets which are accessible, which we can use. So I'm very keen on developing such dashboards and for India, and to make it into one. But I don't want to make so many and different. So one single dashboard for all the data set available at the city or the province level, where anyone can click and download this data set and then use it and help them to decision making. My idea is not just data, but to interpret that data. So the idea is to interpret the data and to see what is talking, and help the government and local authorities to understand and make effective decisions. I will share the slide. There are a couple of links here if you are interested to start Google Earth Engine with QGIS, or with the JavaScript API itself, or with Python. There are plenty of resources. Please go ahead and try. I've published papers. There's a YouTube video of mine explaining my research using Google Earth Engine. If you're interested, please go ahead and please connect with me if you're interested in wetland study and wetland degradation. I'm very happy to work on those. But something which I'm really interested to do with Rohitji and others is, one, I am from Assam, and I'm really interested to make a flood prediction model and a dashboard for Assam. I can calculate flood, and I can do an archive of flood for 30 years. What I need is a help of how can I predict the future. So based on change in the morphology, having certain criteria, how the bank erosion changes the entire morphology, and those I have the domain knowledge for that, and I have a little bit of tech knowledge as well. So combining that, looking for people who can help me to set up a flood prediction dashboard and modeling for Assam. And another which I'm very much impressed by US government does is it's called a digital coast, and I'm highly recommend you to check their website. Something they have on their website is called the sea level rise viewer, which is basically data. It's nothing. They have elevation data of their own land, and also how sea is just a projection really. So how sea level will affect coastal communities. And I trust me, people in Sundarbans, Orissa, Mahanadi, deltaic regions are very much vulnerable to sea level rise, mainly because of land use and destruction of mangroves. And these data sets are not available. So something which once I am ready with the flood dashboard for flood prediction in Assam, or even a simple dashboard which gives you idea of where the flood has affected in last 30 years, and these are the vulnerable areas. The next step which I'm looking forward to do is to have a digital course, a monitoring app or a dashboard for different provinces in India, where you're looking at sea level rise viewer for Mumbai, or for Mangalore, or for Chennai, or you're looking at mangrove destruction, or you're looking at change in sea surface temperature, road distribution, population, and various other parameters. And these, I want to make it very much available for students, for them to use in their projects, so that they don't spend much time. Of course, they need to learn how the data set works and how to calculate, but to spend more time in analyzing spatial patterns. So this is what I really had to share. I've been hopefully by next week I should have a PhD. I'm defending my PhD this weekend, and by next month I will be very much free. Not free is not the right word, but I will have time to work on these projects, open source projects for our community back home by using these technology. And any of you are interested to do so are very much welcome to connect. Thank you very much. I'm sorry if I took so much time. Yeah.
Dhritarashtra, thank you so much. So I'm actually floored. Floored is the word. Yeah, I like using that word. One question I have. So let's say whether it's the coastal plan or the one that you're talking about in Assam. how much of this data is freely available? Because I signed up for Google Earth Engine, I signed up for that Sentinel bet, and I signed up for a couple of these other this thing. Most of them are not very free with their data. So how do we approach this? That is the first question that I have. The second question that I have is, whenever you say prediction, if at your end, and I think everybody will agree with me, if at your end you are clear on as to what are the variables which are going into a particular model, whether it is that, that Google Earth, this thing you showed us where the cart was there, or anything. So as long as you have those variables, I'm sure all of us, we can help you in doing the prediction. The prediction should not be such a big deal to be done, right? So firstly, if you can tell me if there is free data available. Secondly, if you can tell me if there is already clarity on what are the variables. If those two things are there, then I think immediately we guys can start off. There shouldn't be much of a problem.
Yeah, so I'll answer your first question. So data in terms of flood, what we need in flood monitoring is a very high resolution digital elevation model. And the other thing which we need is how I calculated flood is using the Sentinel-2 satellite imagery, and that is freely available. So it's mainly remote sensing data set. So you calculate using satellite imagery. So that is available in freely available in Google Earth, not in Google Earth Engine, but it's freely available by Copernicus, European Space Agency. So that data set is available for calculating of flood. What is not available is a ground data set of population, for example, because these are the flood in Assam are mainly agricultural or in the village areas, and there's less data on road network. There's less data on human footprint, if I may. So that's something data is we don't have. So in order to map vulnerability, if we need to say that this many people will be affected, I don't know how many people live there. I can only tell in terms of land. So I can tell you X square kilometer of the area will be inundated after monsoon season, or after X square kilometer of area in Kaziranga National Forest will be inundated as a matter of fact of heavy rainfall. That I can calculate along. But what I cannot calculate is how many people is going to die, what will be the property loss, because with 10-meter resolution, it's definitely we can map houses, but it won't be that accurate. So that's number one. Number two is about the modeling. Yes, the variables are definitely, it obviously depends what we are trying to predict. For example, if we are trying to create a time series of land use for just the coastal region, and then in order to do so, we need the variables of, for example, what is the land use type, for example, and that comes with local knowledge, of course. So the idea is to have people who actually know what that land is, and then train those models and to see what the predictions could be. But of course, selection of which model to use does require thinking. Are we using CART or random forest, or as you mentioned, SMV? It definitely depends on which model we're gonna use. Yeah. Does that address your question?
Yeah, of course, that addresses my question. Thank you so much. Thanks. Wonderful. Yeah. Anybody else who has any questions right now? There are a lot of things coming to my mind. I think I will get to them later on. Anybody who has any kind of questions, or there's somebody who wants to, maybe leave the call, because it's been almost 1 hour. I will still get into a few things. Past few days, I've been frantically jumping all over the place. I've got about 140 tabs open on my other browser. I don't know how my system is still holding on. So I want to share some of those things with you, because otherwise I'll forget. If I forget, then there's no point. So even if some of you leave right now, that's not an issue. I'll still kind of, end up recording this. You can see that later on. not a problem. Um, anyone who's got a question? Mayank, Rishi, Divyansh, Shubham. I know many guys whom I was expecting are not there, but anybody who's got any questions right now? Okay, so firstly, from my point of view, the way I understand or the way I don't understand GIS, so to say, I had to do a lot of reading up lately. A few things are there. So just like Mayank explained, the raster data is there, and the this other linear format is there. So I'll just share my screen and I'll quickly just go through whatever I can. Whoever wants to stop me, please stop me. And okay, you might see some things which are not very relevant, but I unfortunately didn't have the time to kind of organize myself very well. So if you see something which you don't understand, just ignore it. Okay, now this is QGIS, the open source GIS which is there. Pretty fancy stuff. I used it earlier also. The latest version is really nice. A few things we'll focus on. You can get all your plugins and everything over here. So if I want plugins for Sentinel, Sentinel is that data that right now Dhitraj was talking about, and that's the European agency, and they've got 2-3 different satellites. They have got excellent data from around 2012 and 2015 onwards. This is Sentinel Hub. This is Sentinel. This is another one which is a plugin. Basically, these plugins are nothing but packages. So most of us, we are used to Python packages. These are Python packages, or packages for this GIS, so to say. Most of them are open source. It's good to have a look at them. This is the Python console. So this is basically what we guys call the terminal. This on the right side is where we can end up running our scripts, some of the basic stuff. This is where it says import EE. This is basically Earth Engine. So Earth Engine and things are getting imported in here. The other option with Earth Engine is that you can look at what this person has done. So this there is this. Yes, there's this Chinese professor who's in I think Tennessee, yeah, Memphis, Tennessee, yeah. Yes, I was singing that the entire day yesterday, Memphis, Tennessee. So yeah, he's there, and he's done some projects, and he's done some really good stuff.
Very good stuff.
What I could see was that he's gone ahead and created a wrapper around the Earth Engine, and he's also open sourced his code. So this is the project which is there. What it basically does is it goes ahead and takes the Jupyter notebook and these two other IPy leaflet and IPy widgets, and puts these three together and creates lots of interactive Jupyter notebooks, Google Colab, and things like that. So I played around with some of his code. Pretty simple stuff. So you just basically, over here I'm importing both. So E is the Earth Engine. This is the this thing. The moment you say map, it will open up a world map. So that is by default what is there. This next cell that you see, now let's say if you were just to go over here and I would say London Heathrow, the airport. Okay. Sorry. Yeah, so it will immediately take you there. It will drop a pin over there. So the way it happens on Google Maps and all that.
And Rohit, here you can also search for data set as well. So if you type elevation, it will have all the elevation data set.
Yeah, it will give you a drop down and all that stuff.
Yes.
That will happen with that lat long and other things also. Over here, it will show you what layers it is putting on, whether it's Google this thing engine layer or Landsat or Sentinel or that Modi's or whatever is there. So it'll show those. So I found this thing quite interesting. So what, and especially for developers, if you think of it, here's a map. You've taken this and you've gone ahead and just created. You just put a square over there or a polygon or whatever, and yeah. 1 second. So I think it's taking a few minutes to do that. So what it basically does is, if I say run, one second, let me try that again. So it'll basically create this object. So it's gone ahead and created an object which is the draw last feature object, and which is part of his his map class or whatever is there. And if you go ahead and basically put it into this variable which you can call whatever you want, and if you print it, so right now it is showing me none because it did not do that properly. 1 second, let me do it again. I should not be in a hurry, otherwise. Yeah, so let's say and in case anybody is interested, what I've done is that GIS, this thing that we had created, that organization, I've gone ahead and put all of this code already there. So if you look at this guy's GMap code, I've already put it there, and I've also put the screenshots and everything there. So even if this thing doesn't run live right now, you have all of this code here. So this is how you end up doing it. So this is for some place in Gurgaon. This is for again. So yeah. So this is how you get to see that. So that the feature gets created and ROI and all that stuff, and it's quite interesting what he's done. And yeah, so now let's say, so he's created this Heathrow thing. I think I need to zoom in a little bit more, maybe. Yeah, so this is the Heathrow airport. We can see that, and you create this square overhead, and I just leave it, and I just don't do anything else. And he's automatically going to end up creating one cell over here. Why it is not? Okay, it's still running. Let me see now if it got done. Yeah, it got done. Perfect. Great. So he's gone ahead and mapped all of this into a JSON structure, if I can see that properly. Yeah. He's given the coordinates for this and everything that is there. So great. Now, because I ended up coding it into ROI London Heathrow, whatever. So this is what I do, and I just run this. So what basically will happen now is that a GIF will get created, and that GIF is getting created actually on the Earth Engine this thing. So on their API, it is getting created on this URL. So I go ahead and run that, and the start here I've given is 2000, and what I've said is that there should be 2 frames per second. So starting from 2000 till this year, till 2020, 2 frames per second, it will map each and every year, and it will show you as to what was happening around the Heathrow airport as construction or land use or whatever is there. So a very basic this thing. Now this thing doesn't work, so I won't show you the GIF right now for Heathrow, because Heathrow is not very there was not much happening there, unfortunately. But let me show you for something else I created earlier. Yeah. So this is for Las Vegas. Okay, so this is the default one which everybody is doing, because they can see a lot of water, this thing, and maybe they have data for this. Or maybe the satellite was focusing on Las Vegas versus maybe some other place in the world. I don't know. So they have data right from, I think, 1995 onwards or whatever. So this is the default one. Bangalore, I couldn't do anything. This was again Memphis, Tennessee. I did, which is okay, pretty decent. Again, starting from 2000, I think, till now. yeah, 2000 till now. So you can see that some buildings are coming up, some construction is happening. The river is going slightly dry. The farms opposite are either there or not there, or whatever. They are green, they are brown. So some stuff like that. And this one is slightly faster. So just change those frames and everything. And okay, so this is something else. This is again, how you can coordinates you can capture. Some DB manager is there in QGIS. I'm just quickly hacking through some of these things so that the code is there. You can always look at it. You can understand what is there. It's not very difficult to follow. Yeah. So again, this is the same one which I just showed you. This I tried for Gurgaon, doesn't work. Probably they don't have the right data. This is again one of his example images of that Chinese stuff. This is not something that I've done. What he's showing is on the right side, he's showing one of the, I think, Landsat or one of those, and on the left he's showing Sentinel. So there is the difference over there. And the way he's created his Jupyter notebook and the way he's coded that is that you can end up choosing different data sets over here and visualize them together, which is quite nice. So yeah, okay, and this is my Sentinel login that I created. So it shows me that so many requests were processed. This, that, pretty fancy stuff. So there is a team which is sitting in I think Slovenia or somewhere, and all of this is open source from it's called Sentinel Hub. So they are getting data down from their from Sentinel satellites. Damn nice, a very nice project. It was actually quite impressive. This is within QGIS. So once I've got that Sentinel layer down in QGIS, this is the kind of detail it is showing me. It's saying selected tile matrix set popular, whatever, web Mercator. So that Mercator is some kind of projection that is there in the map. So it gives a whole lot of detail. So I was quite surprised. Whereas I just asked for some default this thing. It gave me so much of detail. And again, you go to their Sentinel Hub, this thing, they've given very excellent documentation. They've basically described as to, what format is there, what layer is there. So I just asked for true color. If you see the layer over here on top, it mentions true color. That's what I asked for. They gave me default, God knows what not. So I obviously don't understand that right now, but then that's amazing. So this is OpenStreetMap. This is OpenStreetMap of Gurgaon. Yeah, so it's okay for a political map. So when we were kids, we used to call it the political map. But this is not a good raster map. So I don't know. Earlier, I think I saw OpenStreetMap raster also. I don't remember right now. But yeah, so it is not that. And if you see on the left side under layers over here, so it says OpenStreetMap and Sentinel. So if I were to plot the Sentinel on top of this OpenStreetMap, then immediately it will show me exactly that location. It doesn't show much intelligent stuff. And while I've done that, my requests have gone from 111 to 338 on this. I'm getting somewhere about, I think, 30K requests for 31 days for free. That seems decent enough for something like Sentinel. Then again, so this one I'm using again that GE map, the Tennessee, Memphis professors, this thing. And I'm doing this for trying to do it for Gurgaon. Didn't happen. Probably they don't have the data. And this is what Dhitraj was mentioning earlier, that if you end up searching just for data and just by maybe some very generic terms, it will give you everything. So it's giving you 10-15 data sets which are there for elevation. It's a drop down. It's a wonderful drop down. I think it's been coded in JavaScript or TypeScript or something. So it's excellent. And down below, so okay, I was running this, and if you see down below, is this me running it, or yeah, it's mine only. Okay. So yeah, if you see down below, no, I don't think so. This is mine. Any which ways, I'll show you another screenshot. So yeah, this is me again trying the same thing. Not enough data. This is the professors. So if you search for a location, it will give you that. So basically, you get to see the Python this thing. Data structures which are there. So you got a list. You got a lot of this thing. NumPy arrays. You have a lot of generic Python in this. So I'm sure any one of you who open this up and have a look at it, you will find it quite interesting. This is another thing that he's showing, that he ended up dropping a pin in some place in Tennessee, and from that he ended up creating this entire Tennessee state or areas. This thing, it's quite interesting. So very flexible stuff. This I was trying to do something for the Bharatpur Wildlife Sanctuary, but nothing turned up. So this was the if you see on the right side, it shows me Google Map, Copernicus, and all these things, but nothing intelligent came out. So I'm not sure if for India there's a lot of things which are there. So this is again a data set within the same this thing called the global human modification. So maybe some human construction and stuff that we've been doing, and now that is being mapped. Again, I just kind of went through it, did not spend much time. So yeah, and this is the one where I created that Memphis, Tennessee 2000 till date thing. Okay, now this is again back in QGIS. So within QGIS, the Landsat 8 original image and all that, how that is coming. That is again coming through this Earth Engine scripts which are there. So okay, once you zoom in, so this is not the real color. There is some false color and stuff like that. Once you zoom in, it's not very clear, or it's not something which is very fancy. Yeah, but maybe then I don't know how to use it well enough. So that is one. Yeah. So any questions for me? Anything? So all of this I've put it on my GitHub. Very easy. Anybody who, why should I say anybody? All of us who are already doing the things that we are doing, I'm aware. If you guys go through this, it is very easy for you to understand. So I think I just did it in past 2 or 3 days. Any questions anyone has? Anything that's coming to your mind right now? Shubham, Rashri?
No, so now I don't have any questions.
Yeah, so maybe we should all explore all of these things, and then we should get back to Dhritaraj as to how we want to participate, what we want to do, and it's the same thing like we've been doing earlier, right? So we'll open source the entire thing, and whichever way we want to participate, we should be comfortable. Shubham, any questions?
Actually, I have a question. What do you want to do actually? Do you have any idea or any like?
Rashi, I'll come back to your question. Krishna?
I'll have to research more into this before, so that I could understand what.
Yeah, Shubham, I'm also kind of just jumping through things right now. So it's basically what Dhitraj has already told us. So Rashri, answering your question, what we want to do is ultimately predictive analytics. So it's as simple as that, right? So even he and me, when we had the initial conversation, I told him the same thing, that let's say we were not to look at what the professor has done or what Google Earth is giving or whatever, and we go ahead and take Sentinel data, or we go ahead and take some raw this thing which is available to us, and we go ahead and create a web app. So again, I don't want to go into that detail, but already I've kind of snooped around. Not many people are doing that. It's not something which is that difficult. Somebody is using the Mapbox API. Somebody is using a lot of front-end JavaScript, doing a lot of things over there. So creating web apps with Leaflet, with this thing, all those things are there. But the predictive is what is the challenge. So ultimately, that's what he also wants us to do. So how do we get into modeling some of this data? How do we end up predicting some of those things? Is what is going to be exciting, and is what is going to be challenging. So otherwise, I don't, unless of course you want to move into GIS as a field of work and things like that. That's a different story. Then it's a huge thing to get into. But from a narrow scope to narrow down the scope, I think it is best to look into something as predictive analytics on the geospatial data, and that is what Dhitraj also wants, right?
Yes, exactly. So you're looking at, for example, you want to, for example, I'm from Guwahati, and I want to see what could be the extent of urbanization that after 50 square kilometer of urbanization, you have to say that this is the limit. You cannot again expand after this because there is a forest, because there is a resource. And in order to predict that, you need a land use data set for about 30 years, and then to see that, to create three scenarios and to see that if we continue with the same pattern of urbanization, or we do a little bit less, or we do in a different way. So those predictive analysis in terms of land use planning is quite useful for as we look at cities. And these could be applied for the various different aspects. For example, flooding, for example. Now in flooding, for city like Guwahati, you need data set about drainage, for example, and you need data set about clogging, drainage clogging, and there that comes with ground knowledge, of course. But with satellite remote sensing, what we can do, we can monitor Brahmaputra, and we can see how the course is being changed every month. You can do it monthly, you can do it weekly, because Landsat is every 5 days revisit time. So you're looking at 2 weeks, for example, 2 weeks change in a river course, and that is very, very useful, because once you have a 2 week scale data set for 35 years, that gives you an enhanced accuracy to see what we can predict of how a monsoon rainfall of more than 100 centimeter can do to a river bank erosion. And that's very powerful predictive analysis.
Rashri, the other this thing which I think I shared last time also on that call when Aman was there, and Aman suggested, Aman is still here, so that's the reason I'm referring to that. Uh, I was very much interested in building footprints. So there is something called building footprints, and again, it's similar to land use.
Yes.
What is the and people have already done that. So day before yesterday only, somebody contacted me on LinkedIn saying that we are already doing this. I was quite surprised to see how easily they've gone ahead and created that. So maybe it is created as a wrapper. That software is created as a wrapper around maybe something like QGIS, or maybe some other this thing. Maybe it's some CAD kind of software. I don't really know. But there is a lot of work in this field. See, firstly, you need to, like Shubham says, I would want to research more into this. I've been researching whole lots into this past about almost a week now. There is a lot of potential for work. There's a lot of people doing a lot of things in this. Now, how, let's say we were to monetize it. Okay, let me come to that. That we were to monetize it, we were to give some kind of thing that we end up creating to somebody, then who is our target? Who is the person who will pay us for something of this sort?
I have an idea.
Yeah, please go ahead.
Looks, and it's actually with my brother and I. We've been talking, like, especially the telecom industry. For example, Airtel and other, they need a huge amount of data set of especially building footprint, for example, because their telecom industry requires a very, for especially 5G, because they need a very enhanced, very high quality data set of urban dense urban vegetation in the urban area, as well as road network and building footprints. So if you want to monetize GIS, telecom industry is one of the in one of them biggest client, especially in Europe. There in China is huge. GIS is huge in remote sensing, especially for telecom industry. That's one, and another one is real estate, of course. and it comes as a package. It comes as a tool. So you have a tool which has different layers of information, like your digital elevation model. You have a human footprint, building footprint, vegetation, trees, and you set up as a package. And then they have their 5G algorithms in it, and they see how their propagation of the signal happens in terms of the terrain, in terms of the buildings, in terms of vegetation, and that's one of the applications if you want to monetize it.
Yeah, and solar, this thing, PE deployments and all that. That is what I discussed on the call earlier, and that call is recorded. So in case somebody wants to, go back to that, and that is where me and Aman ended up having that discussion of ours about augmented reality. And Aman suggested that yes, Rohit, if there is somebody on the ground, so like Dhitraj, that is what you also mentioned day before yesterday, that
Yes.
ultimately you will want people to be on the ground to share the ground truth. And like I said, so you have friends in Guwahati and all that. That's okay, but then maybe if you commercially start looking at it. So let's say you have remote sensing data and you have ground truth data. Okay, ground truth data is something which will, again be dependent on human being. Yeah, it'll
Yes.
enhance, right? But it'll be dependent on human beings
Yes.
to a great extent, measurement and
Yes.
all that.
Yes.
And again, man in the middle kind of a thing is there. So which is not very time effective. It is not very accurate, is what I understand from from some people in civil engineering and things like that. So if there you get something which is maybe, I don't know, maybe augmented reality or maybe lidar. And lidar is again, so I wanted to spend some time on lidar also, but I think enough time is already spent. It's already more than an hour. Lidar is quite excellent stuff, and lidar is not something which is right. So Mayank is right. Lidar is latest in India. Lidar is getting famous now. That is okay. But lidar in GIS is almost, I think, about 20-25 years old, if not more.
I have just shared a link for LiDAR course I came across from NASA. It's a free course. Anyone can join and learn.
Perfect. This is great. Yeah. And so, I saw this video about lidar from Australia. There's somebody who did it in Australia, then went off to Canada to kind of give that talk. And I saw that in quite detail. So lidar is amazing stuff. So lidar from drones. Again, on this GitHub repo that I shared with everybody, I did put something for lidar also. Yeah, that's one only, na. Last tools. Look at this guy. This guy, the one who has made this last tools, he was a professor somewhere in the US, and he's done this, I think, almost 15-20 years back, and he's given a presentation. That presentation is there on YouTube. I was listening to that guy. He's openly saying that, Esri is trying to do something. He's randomly referring to Esri as if Esri is somebody, bunch of kids sitting in the next door house. And he's not given his last tools to Esri that time. He's gone ahead and created his own thing. And that last tools is being used in, QGIS right now. It's amazing stuff. I was actually quite surprised to see how amazing that guy's open sourced this thing. I think it's C++ or something. It's amazing, that library. So people have done so much work. It is just that awareness is not there, and maybe awareness is starting now because the satellite imagery and this drones coming up and all this. Before drones coming up, it was difficult to get a lot of lidar data out. And I've shared somewhere. I don't know. Maybe again I put it in that GitHub repo only. I'll create good markdown files so that everybody can get to read what all stuff I put in there. But I've already put it in there. There is a company in Bangalore who's doing some excellent work with drones. So they're flying all over Bangalore. They did that, I think, right now for the coronavirus thing also. They did it for Bangalore police to basically check if the lockdown was effective or not. Not only that, I think somewhere there was in Rajasthan, I think Mayank will be aware, there was a locust, this thing which was there right now, right? About just 2-3 weeks back. So the government has sent drones over there to spray this thing. So drones are becoming very common. Drones are becoming common. The lidar data will become common. It is not there right now, maybe. Yeah, Mayank is saying, yeah, that's true. So all of this is all over the place right now. So this is the right time to maybe jump into this to try and understand what can be done. The biggest challenge I see is understanding the geospatial part of it. Uh, uh, Understanding like what are the different categories of images that are coming through, how to get those images, for which area those images are available, what does it mean by having these different bands. So there's a whole lot of these different bands and all that which are there. Some are in the visible this thing spectrum, some are in the not visible spectrum, the infrared spectrum. Understanding all those things and using which data set for what work and how to get that data set is the only thing which I see. Besides that, there is so much code, there is so much examples. Anybody who wants to, and somebody like Shubham, Rashri, Krishna, I know you guys very well, right? So, Aman, if you guys spend maybe 1 week or max to max 2 weeks on any of this, I'm sure you'll be able to, understand the entire picture quite clearly. I don't have any doubt in that. And then there is Dhritaraj, then there is Mayank, then there are others who are ready to kind of collaborate with us on this. Let's understand what the projects are and let's participate. Let's collaborate. Why not? Let's open source some stuff. Yeah, and that's all I had to say. So Rashri,
Yes.
do I answer your question?
Yeah, I understand.
Yeah, so you understand the way I think, right? So why not?
Sorry, everyone. I have to drop off from the call for now. But I have shared my email address, and anyone would love to connect. It's 11 p.m. and right now because of COVID-19 situation, I cannot be in the department after 11.
Yeah, please. Thank you, Dhitraj,
Yeah.
and
Yes.
wonderful. Thank you so much. I'll share this on YouTube
Yes,
also.
please. And
And
anyone, if you want to connect with me, I have given my email address, and please get in touch, and we'll be catching up again soon.
we'll do that very soon. You need not worry. Yeah. Thank you so much.
Yes.
I'm
Thank you.
absolutely grateful for this.
Yeah, me too. Me too. Very nice. Thank you so much. Bye. Take care, everyone.
Thank you so much. Bye bye.
Bye bye.
Guys, any other questions? Anything that you want to discuss now? Hi, Nurul. How are you? Long time.
I'm fine. Thank you. How are you?
I'm good. I'm good. So yeah, it's been a long time. Haven't interacted with you.
Yeah, thanks for inviting me. It's a very interesting stuff, and I did not wanted to
You
miss it.
you most welcome. Most welcome. Perfect. So in case no other questions for now, I'll share a lot of things that I actually didn't get my get much time to organize my sharing. So I've just been dumping whatever. I'll do that, and thank you so much, Mayank. Thanks a lot. Wonderful interacting with you. Uh, we'll all be in touch with you very soon again, and
Looking forward to it.
thank you, man. Thank you so much.
You're welcome.
Thanks,
Thank you.
Aman, Krishna. Thank you so much for attending the session. Please get in touch with Dhitraj and Mayank. Connect with them on LinkedIn. Let's see what we can do. Thank you so much. Bye bye.
Bye.